Good morning. So today let us discuss about atomic mass, molecular mass, gram atomic mass, gram molecular mass, formula mass and then the mole concept. So let me start with atomic mass. What is atomic mass? Atomic mass is basically the mass, the measurement of mass of an atom, and it is measured in unit U. In yesterday's class, you noted that 1/12 mass of carbon 12 is known as 1U. It is also known as 1 AMU. So 1/12 the mass of carbon 12 atom is known as 1. U stands for unified mass, 1U, which can be also written as 1 AMU. In this unit, we will study about the atomic masses. So we can write the mass of hydrogen atom, single hydrogen atom. The mass of single hydrogen atom is 1U. In reference to carbon 12, 1/12 the mass of carbon 12. In reference to that, we can write the mass of single hydrogen atom as 1U. The mass of single nitrogen atom is 14U. The mass of sodium atom, Na, is 23U. We can write the mass of aluminium atom, 27U. So how can we define atomic mass? Atomic mass is the factor by which an atom is heavier than 1/12 the mass of carbon 12. Say that 1/12 the mass of carbon 12 is X. So we can say that by what factor? Y into X. Let me write. Let 1/12 the mass of carbon 12 be X and the factor be Y. So Y into X. Y is the factor. Y is 1 in case of hydrogen, Y is 14 in case of nitrogen, Y is 23 in case of sodium. So atomic mass is the factor by which an atom is heavier than 1/12 the mass of carbon 12. So what about molecular mass? Molecular mass is the mass of a molecule. Let us look. We are mainly considering covalent molecules. Let me take an example. We can take initially hydrogen molecule H2. So okay, H2. So what is the molecular mass of hydrogen? It is 2U. Okay. What will be the molecular mass of fluorine? F2. So in case of fluorine, the molecular mass will be 38U. In case of chlorine, the molecular mass is 71.5U. Okay, 71.5U. We can take a compound CH4. CH4 is methane. Methane, you know, carbon 12. Then what about hydrogen? 4 into 1. So methane, it is 16U. So this is molecular mass. It is the mass of a molecule. So how can we define molecular mass? It is the factor by which a molecule is heavier than 1/12 the mass of carbon 12. The factor by which a molecule is heavier than 1/12 the mass of carbon 12. What is 1/12 the mass of carbon 12? That is 1U. So how can you write 2 into 1U is what of hydrogen? What about fluorine? It is 38 into 1U. Okay. Now we will discuss what is gram atomic mass. Atomic mass which is described or illustrated in the unit of gram is known as gram atomic mass. Let's look. Hydrogen. The gram atomic mass of hydrogen atom is 1 gram. That is atomic mass represented in gram is known as gram atomic mass. Very simple. You can just change the unit from U to G. Let us look another. What about gram atomic mass of fluorine? It will be 19 gram. I am taking fluorine atom. What about another? When I will take chlorine. Chlorine will be 35.5 gram. Actually, these molecules, these hydrogen, fluorine, chlorine, the excess diatomic molecules, but for simple calculation, I am taking as monoatoms. Okay. So gram atomic mass is simply atomic mass represented in gram. What will be gram molecular mass? That is molecular mass expressed or represented in gram. So let's look at other examples. Let's take ammonia, that is NH3. You know nitrogen's mass is 14. What about hydrogen? 3 into 1. So total mass of ammonia is 17 gram. Okay. So ammonia's total mass, gram molecular mass is 14 plus 3 into 1, that is 17 gram. Let's take another one. Hydrogen itself, H2 molecule. So gram atomic mass of H2 molecule is 2 gram. Very simple. You can make atomic mass to gram atomic mass by simply changing the unit from U to G. And you can change molecular mass to gram molecular mass by simply changing U to G. So we have discussed atomic mass, molecular mass, then gram atomic mass, gram molecular mass, and how to convert each of them. Okay. By now, we have already discussed how to calculate the masses of monatomic gases as well as diatomic molecules. Basically, diatomic molecules are having covalent bond. Now we will further discuss about how to calculate the atomic or molecular mass of ionic compounds which have electrovalent bonds in them. The method is same, but the term we use is formula mass. Let's look with an example. An ionic compound is NaCl, sodium chloride, normal table salt. NaCl exists as Na plus and Cl minus with a coordination number 6:6. That is 6 Na plus will be surrounding chlorine atoms as well as 6 chlorine atoms will surround sodium atoms. So their coordination number, this is the coordination number. Coordination number is 6:6. These things we will be studying in the chapter solid state. Okay. However, we know that NaCl will be dissociating into Na plus and Cl minus. Now how to calculate its mass? You know the mass of Na is 23 in U and what of chlorine is 35.5 U. So the total mass is 58.5 U. Or we can write it in terms of gram. No issues. That is known as gram formula mass. Formula mass is 58.5 U. If you are asked to write gram formula mass, you can simply write 58.5 G. So when we in what situation we use formula mass? We use formula mass in case of ionic or electrovalent bond, that is basically ionic compounds. I will give some examples. We can use for NaCl, then we can use for KCl, that is potassium chloride, we can use for potassium bromide, we can use for sodium Na2CO3, sodium carbonate. So these compounds are ionic bonds, so we can calculate formula mass. They are basically molecular mass, but it is of ionic compounds. Okay, you got the concept? Now, let us discuss about another concept, that is equivalent mass. So first of all, let us put up the equation for equivalent mass. Then we will come to its definition. So what is the equation for equivalent mass? Equivalent mass is basically molecular mass divided by, it is molecular mass divided by valency. If you divide the molecular mass of a substance by valency, you will get equivalent mass. We can study it with an example. Let us consider oxides of copper. First of all, we will take CuO. First example, this is copper oxide, in which oxygen is -2 state, copper is in +2 state. Okay. So in this, the equivalent mass of copper is which is equal to mass of copper divided by its valency. Valency is 2. We can take the next example. Let it be Cu2. In this, oxygen is in -2 state and each of the copper atom is +1 state. Overall, Cu2 is in +2, but individually an atom is in +1 state. So which can be in this equivalent mass of copper is mass of copper by 1. The valency is 1 here. So basically it is mass of copper. Mass of copper is basically 63, nearly 63.5. Let's take 63, 63 by 2, it will be 31.5 and this will be 63 itself. In U, we can write it in U. So from this, you can understand that equivalent mass is not constant. You know that for a particular atom, atomic mass will be constant. For a particular molecule, molecular mass will be constant. For a particular ionic compound, formula mass is a constant. But equivalent mass will differ according to the reaction or according to the compounds. So each atoms or each compounds will be having different equivalent mass according to their situation. So what is basically equivalent mass? How can we define it? It can be defined as the parts by which a substance can combine with one part of hydrogen or 8 agility can be with the mass we will take 1 gram or 8 gram of oxygen or 35.5 gram of chlorine. Simply saying equivalent mass is in what ratio whether the two atoms are combining. So how can we write the equivalent mass of an acid? Equivalent mass of an acid is mass of acid, that is molecular mass of acid, the net mass of acid divided by basicity. What is basicity of an acid? Basicity of an acid is the number of ionizable H plus. How much H plus can be liberated? What is the basicity of H2SO4? The basicity of H2SO4 is 2 because it can liberate 2H plus. Okay, this is basicity. What is the basicity of HCl? It is actually 1 plus 1 because it can liberate 1H plus. Okay, so basicity is the number of ionizable hydrogens. So what is the equivalent mass? We will write an example. Equivalent mass of H2SO4. That is the net mass of H2SO4 divided by 2 because the basicity of H2SO4 is 2. Equivalent mass of HCl will be mass of HCl by 1 because the number of ionizable hydrogen HCl is 1. This is in case of acid. But we have an exception here. The usual question that arises about orthoboric acid, or we can call it as boric acid, that is H3BO3. So by seeing this, we are tempted to write the equivalent mass of orthoboric acid or boric acid is mass of H3BO3 divided by 3 because we see here 3 hydrogen atom. But actually this is a Lewis acid. This is Lewis acid. So what is this issue? Let's look. Actually these 3H plus hydrogen atoms are not ionizable. The method of liberation of H plus ion is different in case of boric acid. Let us find it how. H3BO3 exists as, it is basically BOH thrice. H3BO3 can be written as BOH thrice. It will react with water molecule and form BOH4 minus and H plus. Actually this H plus is the one which is liberated. Due to this H plus it is showing acidic character. So this is wrong. The equivalent mass of H3BO3 is not the net mass by 3. Equivalent mass of H3BO3 is net mass of H3BO3 by 1 because we find that there is only one ionizable hydrogen. Basically that is coming from water. So this is a weak Lewis acid. This is a weak monobasic Lewis acid. So now what is the equivalent mass of a base? So we can write equivalent mass of a base is equal to net mass of base divided by acidity, which is basically the number of ionizable OH minus ions. Let's look. The equivalent mass of NaOH, the equivalent mass of NaOH is equal to mass of NaOH divided by 1 because only one OH minus in NaOH. Let's take the next example. We will take equivalent mass of MgOH2 as magnesium hydroxide, milk of magnesia we call it as. So what is the equivalent mass? Equivalent mass is mass of MgOH twice divided by 2 because we have 2 ionizable OH minus. Let's take the equivalent mass of AlOH thrice, that is aluminum hydroxide. So what is the equivalent mass? Mass of aluminum hydroxide divided by 3. So the equivalent mass is basically the molecular mass by valency, or we can write molecular mass by basicity or molecular mass by acidity. Now the next part we will discuss how to calculate the equivalent mass of an oxidizing an oxidizing or reducing agent is given by equivalent mass of oxidizing or reducing agent is given by net mass divided by, that is the molecular mass divided by number of transferred electrons, that is number of gained electrons or number of lost electrons. So equivalent mass of an oxidizing or reducing agent is given by the net mass divided by number of transferred electrons. Let's give an example. Let's take a compound KMnO4, that is potassium permanganate. So potassium permanganate in acidic solution, it acts as an oxidizing agent. So the reaction follows as MnO4 minus plus 8H plus 5 electrons gives Mn2 plus 4H2O. So this is the equation of potassium permanganate in acidic medium. Okay. So what will be the equivalent mass of potassium permanganate in this reaction? In this reaction, equivalent mass of KMnO4, the equivalent mass of KMnO4 is equal to the net mass of KMnO4, the net mass of KMnO4 divided by the number of electrons. Here, what is the number of electrons? 5 electrons. Right? How can you find it? Here it is manganese in plus 7 state. Here it is in plus 2 state. How much electrons? 5. Right? That is basically by this factor the oxidation state is reduced. KMnO4 actually had undergone reduction, but it acts as an oxidizing agent. Oxidizing agent will undergo self-reduction. So we can write equivalent mass of KMnO4 in acidic medium is equal to net mass divided by 5. We will discuss the related equation in the chapter D block. We will study these equations in the chapter D block. So what about in neutral? In neutral medium, this is net mass divided by 3, and in basic medium, the calculation we will study in D block. I am just giving you the final answers. In basic medium, you will get the answer net mass divided by 1. Okay, so KMnO4 is having different equivalent mass in different solution. The equivalent mass is differing in acidic medium, it is differing in neutral medium, and it is something else in basic medium. So you have detailedly studied about calculation of equivalent mass. We said equivalent mass is the molecular mass by valency, then we said the mass of acid divided by basicity, then mass of base by acidity, and now it is the net mass of oxidizing or reducing agent by the total number of transferred electrons. Mass, molecular mass, gram atomic mass, gram molecular mass, then formula mass, and the different methods of equivalent mass calculations, that is of acid, base, then oxidizing or reducing agent or a normal reagent. Okay, thank you.